Okay, hello. Today we are going to talk about the difference between three types of major functions that Algebra 1 standards cover. So we have linear, exponential, and quadratic. We've definitely covered linear functions. We've covered exponential functions in quarter 3. Quadratic is our newest function. On the left-hand side, we're going to look at how their graphs compare, how their equations compare, and how their patterns in the tables compare. So set up your notebook page like this, as a full page in your notebook. So there's a lot of room down at the bottom because the table patterns, they all have their own different patterns, and so I want to show that pretty good. So on that top one, I have about 1, 2, 3, 4, 5 lines for the graph section. All right. Let me get situated here, and then we can get started. There we go. So, first let's look at linear graphs. What do linear graphs look like? You're right, a line. You could have positive sloped lines. You could have negative sloped lines. You could have horizontal linear functions. Exponential functions. Those are a curve, if you remember. You could have exponential growth, or you could have graphs that have exponential decay. And remember, they have that like asymptote, doesn't go below that line. Quadratics are our newest function. Quadratics look like this on a graph. Every time. You've seen quadratics from last chapter. We kind of introduced them. They look like a U. They can be opened up or they could be opened up down. They could also be very wide and they could be very narrow, and we're going to get into that next chapter. The U-shaped graph actually has a special word because we're not going to walk around calling that, oh, it's a U. No. It's called a parabola. Say it. Parabola. That's what the U-shaped graph is called. The exponentials, we just call those like a curve. The linear functions, those are lines. Okay, so part of the standard for Algebra 1 is, given a graph, can you tell what type of function it is? Name that like family. Next, we're going to look at their equations and how they differ, because in Algebra 1, part of the standard is looking at the equation function and telling what type of function it is. So lines, here's an example. I'm going to use f of x for all of them too. F of x equals x. F of x equals 1/2 x plus 2. You might see a line equation that looks like f of x equals negative 10x. So most lines are in the format of, I'm going to write f of x, but remember f of x, just replace that y, that mx plus b. Y equals mx plus b. We can add that too. Oh, I don't need a quote here. Actually, we can also put in f of x, oops, not f of 5, f of x equals something like 80, a constant. That would have been a flat line or a horizontal line. Let's talk about exponential equations and what they look like. Here's some examples. Remember exponential? The word exponent is in there. So one example is f of x equals 2 to the x power. Make sure you make that x like a flying high up in the air, the little exponent. F of x equals 10 times 1.07 raised to the x power. Remember we did that whole unit on if it increases by a certain percent every year. f of x equals 8 times 0.92 raised to the x power. Those are all exponential functions. So what do they all have in common? Well, these are in this format. F of x equals a times b to the x power. They all have an x up in the exponent. X in the exponent. Circle that x. Quadratic functions. So these are our newest functions, so we're not as familiar with them. Here are some examples, and maybe you can tell why these would be considered quadratic. F of x equals x squared, or x to the second power. That's a good example of a quadratic. F of x equals 3x squared plus 5. That's an example of a quadratic. F of x equals x minus 4 squared, and then a plus 10 on the outside there. That whole line here, that equation, that function, that's a quadratic function. F of x equals x squared minus 7x minus 8. That's a quadratic function. So we've seen these last chapter. Quadratic functions tend to be in two different formats that you're going to learn about. One is this form, ax squared plus bx plus c, or another format which we're going to do next chapter, but it's good to throw it in here, a times x minus h squared plus k. That will be in the next chapter, or next half of the chapter. Now, what do all of these functions have in common? Think about it. Kind of look them over. Okay, I heard someone in the back there. You're right. They all have a little squared. They have the highest degree is a 2. That's what makes it an quadratic. So, part of the Algebra 1 unit, standards, ask you, if you look at an equation, would you be able to tell what type of function it is? And for Algebra 1, these are the three main functions. So later on, you'll definitely be asked those type of questions. This is such a good go-to page for your notes. Zoom up. Now let's look at their table patterns. I'm going to give you 3 tables. So why don't you go ahead and copy those down. We're going to do the same x's for each of them. And we're really going to focus on those y values or f of x values. Okay. Okay, so take a second to copy those down. So the table pattern, let's look at linear. What kind of pattern are you seeing? And we just want to focus on that y side, just because all their x's are the same. Just that y. It's like, what makes this table create a line? Because it will create a line. You can put it into Desmos if you want to, if you don't believe me. But it will create a line, but let's look at y. When we look at table patterns, we typically look to see from one y value to the next, like what's happening. So from -5 to -2, think of that on a number line. That's increasing by 3. -2 to 1, that's also increasing by 3. 1 to 4, increasing by 3. 4 to 7, increasing by 3. There you go. Looks like a pattern to me. What do we call that pattern? Whoop. Well, for a line, when it's just adding 3 every time or subtracting 10 every time, this is called a constant rate. Now, we are going to get a little more specific in a little while, but you'll see. Now let's look at exponential. So here's your exponential table. If you don't have it copied down, make sure you've copied that. What pattern do you see with those numbers, those y values? How do we go from 10 to 20, 20 to 40, 40 to 80, 80 to 160? How do we maneuver that? What pattern is happening? And maybe you thought, oh, plus 10. But 20 plus 10 is not 40. So 10 times 2, hopefully you saw that. Exponentials, if you remember, they have a multiplier. All right, and now we have our newest function, which looking at this table, I'd be like, looks like any other table to me. Well, you're right, they all do. That's why you have to kind of take a second to look at the number patterns that are happening. So 5 to 4, that's going down, but then 4 to 5, that goes back up. And then it goes up, and then it goes up. But since it went down, and then up, and then up and up, it's not gonna be a constant rate. Now I also don't see a multiplier, because if I multiply 5 by something to get 4, I'm going down. So that'd be multiplying by a decimal. But then I'm going to go back up. So with the quadratics, let's look at another pattern. 5 to 4 definitely goes down by 1. 4 to 5, well, that goes up by 1. 5 to 8, that goes up 3. And 8 to 13, that goes up 5. This is not a constant rate. So right off the bat, it's not linear, not a constant rate. But if I look at this rate right here, I see a pattern. -1, if you look at a number line, -1, 1, 3, 5, they are all how many numbers away from one another on the number line? -1 to +1, that's a jump up by 2. 1 to a +3, that's a jump up 2. 3 to 5, that is a jump up of 2. So what do we call this? Because it's like we can't say constant rate because that would be linear. So what we call this part, this is called first differences. These, for your quadratics, circle them, make a cute arrow. These are called second differences. Yeah. Your second differences are constant. And if you remember, I said we would go back to the constant rate. We sometimes call this also first differences. So that's your new piece of learning for today, because we've done exponential and linear a lot this year, but the quadratic column is all the stuff that we've learned today. So, recap. You've learned that the quadratic graph is called a parabola and it's a U-shaped curve. You've learned that quadratics have a highest degree of 2 in their equation. And you've learned that quadratics have second differences are constant, or second differences in common. So make sure your notebook looks like mine. This is a great go-to page for exam, for a test. And I hope you have a great day. Miss you.